Zuera?
75%.
You're right. Now I'll say to 2. Find the mechanical power that can be delivered by a 24-volt DC electric motor when it draws 1 ampere and operates with an efficiency of 80%. Yes, Bosoma?
19.2 watts.
You're right. It's not available. If you were to present it to the right number of significant figures, what would it be for the information you were given? No, that's not the right number of significant figures. That would be 19 watts, right?
Okay.
You would use one more significant figure than necessary, but it doesn't matter. All right. Edinaman, find the efficiency of an electrical appliance which draws 5 amperes on a 200-volt circuit while producing an output of 900 watts. Yes, Patrick?
90%.
You're right. For the next set, I think you can manage in 10 seconds, and I have a preamble to all schools. I'm going to give you a set of organisms when I get to your school. Please identify the producer among the following organisms. Right? Okay, so now, tamale, worm, fungus, green algae, termites. Yes, Uwera?
Green algae.
Yes. With the same preamble, or say to 2, zooplankton, copepods, phytoplankton, tilapia. Yes, Kadil.
Phytoplankton.
You're right. With the same preamble, earthworm, cyanobacteria, millipede, centipede. Lorenda.
Cyanobacteria.
You're right. Tamale, give the symbol for the element mercury. Yes, Zuera?
Capital H small g.
Okay. Patrick?
Capital A, small t.
Yes. Next set, 30 seconds, and you have a preamble. Preamble to all schools. Find the next term in the sequence. That's the preamble. All right, so now Tamale, 2, 6, 12, 20, and so on. Zuera?
30.
You're right. Osei Tutu with the same preamble. 5, 10, 17, 26, and so on. Yes, Kadil.
37.
You're right. With the same preamble. -7, 0, 9, 20, and so on. Yes, Patrick?
33.
You're right. You people are making me so happy. Next set, 30 seconds. Tamale. The initial velocity of a particle moving along the x-axis with constant acceleration is 20 meters per second. Find the acceleration of the particle if its velocity at t equals 5 seconds is 40 meters per second. Zuera,
4 meters per second squared.
you're right. Osei Tutu. The acceleration of a particle moving with constant acceleration along the x-axis is 2 meters per second squared. Find the velocity of the particle at t equals 5 seconds if its initial velocity is 10 meters per second. Kadil.
20 meters per second.
Yes. Not available. Your own question. Find the initial velocity of a particle which moves with a constant acceleration of 8 meters per second squared along the x-axis and whose velocity is 50 meters per second at t equals 10 seconds. Patrick.
It has a velocity of 30 meters per second.
That's incorrect. Who? Okay, Osei Tutu Kadil.
Negative 30 meters per second.
Yes. Next set, 10 seconds. I'm going to present your schools with some kind of event, okay? So mention the stages of meiosis during which the event I tell you takes place. Is the preamble okay? Is it okay? All right. So now, Tamale, homologous chromosomes pair up and form synapses to become bivalent. Zuera?
Professor 1.
Yes. With the same preamble, or say to 2, nuclear membrane begins to break down. Yes, Kadil?
Anaphase 1.
That's incorrect. Yes, which of you, Zuera?
Professor 1.
Yes. Edinaman, when sister chromatids get separated. Yes, Lorenda?
Anaphase 1.
Yeah, no, that's incorrect. Yes, Kadil?
Anaphase 2.
Yes. Next set, 30 seconds, and a preamble to all schools. Preamble. A glass vessel at 30 degrees Celsius contains 2 moles of oxygen gas, 3 moles of nitrogen gas, and 4 moles of helium gas. And the total pressure of the 3 gases is found to be 360 kilopascals. Did you get your preamble? Okay, no response means yes. Now, Tamale, calculate the mole fraction of oxygen gas and give your answer to 2 places of decimal. Yes, Zuera?
0.22.
Yes. With the same preamble, or say to 2, calculate the partial pressure of nitrogen gas. Yes, Bosoma?
120 kilopascal.
Yes. With the same preamble, calculate the combined pressure of nitrogen and helium. Yes, Patrick?
280 kilopascal.
Yes. Last set of questions for the round, 30 seconds with a short preamble. Preamble to all schools. Solve the equation for x. Now, Tamale, 4 raised to the power of the expression 2x minus 3 is equal to 16 raised to the power of the expression negative 2x plus 1. Zuera,
5/6.
you're right. Osei Tutu, 3 raised to the power of the expression 3x plus 2 is equal to 9 raised to the power of the expression x plus 2. Kadil?
X equals 2.
Yes. Last question, Edunaman. 7 raised to the power of the expression 4x is equal to 49 raised to the power of the expression x minus 2. Yes, Patrick?
X is equal to negative 2.
You are right. Well done, well done, well done. That's the end of the first round. At the end of that incredible first round, Edunaman Senior High School has 18 points. Osei Tutu Senior High School has 23 points. Tamale Senior High School has 25 points. Well done once again. 4 more rounds to go. Round 2. This round is also known as a speed race. Questions in the round are thrown to all 3 schools simultaneously. For an opportunity to answer a question, you need to alert me by ringing your bell. May I hear your bell, Tamale? Thank you. You're also Edunaman. Thank you. And you also say Tutu. Thank you. If you ring an answer correctly on the first attempt, 3 points. On the second attempt, 2 points. On the third attempt, 1 point. There's a small caveat. If you attempt the question and you are unable to answer correctly, it fetches a penalty point at every stage. If the question involves calculations, you have 30 seconds maximum in which you have to present an answer. If there are no calculations, 10 seconds. Best wishes, everyone. For this first set of questions, only 10 seconds necessary. All right, first question. Which division of the nervous system is responsible for fight or flight response? Okay, I'll say Tutu.
That is it. Parasympathetic.
That's incorrect. Who rang? Yes?
Peripheral nervous system.
No. Did you ring? You don't want it? Okay. It's a sympathetic nervous system. Second question. Name the phase of meiosis during which DNA begins to condense. Edinaman?
Prophase 1.
Yes. A patient who is severely dehydrated accidentally receives a large transfusion of distilled water directly into a major blood vessel. What will happen to the blood cells? Yes, Tamale.
Up and best.
Zuwera.
They will swell up and burst.
Yes. For this next set of 3 questions, 30 seconds maximum. Express tangent of 190 degrees as the tangent. Go ahead, Patrick.
Tan 10 degrees.
Yes. For those of you who are not so fast, the question was express tangent of 190 degrees as the tangent of a positive acute angle. And yes, it's 10 degrees, tangent of 10 degrees. All right, next question. Okay, maybe I should give you 30 seconds for this next one. Okay. Yes, it's 30 seconds for all of them. So, factorize completely. 2x squared minus 9x plus 10. Which of you, Bosoma?
Madam, in one bracket, the expression 2x minus 5. Multiplying in another bracket, the expression x minus 2.
You're right. If f of x is equal to 2x plus 3, and g of x is equal to x squared plus 2, find an expression for f of g of x. Yes, Zuwera,
2x squared plus 7.
you're right. Next set, all 3 questions, 30 seconds. Calculate the pH of a BaOH2 solution whose 250 centimeter cubed of a 0.010 mole per decimeter cube solution is diluted to 500 centimeter cubed with deionized water. Yes. Zuwera?
12.
Yes. Calculate the volume of oxygen at STP liberated at the anode during the electrolysis of molten Al2O3 after 0.1 Faraday of charge. Yes, Zuera.
0.56 dm cube.
Wow. Next question. Yes, you didn't even wait to receive the volume of a gas at STP. Huh? You know that already. All right. Next question. The maximum volume of an inflatable plastic balloon beyond which it will burst is 2.9 decimeter cubed. Determined by calculation whether 4 grams of oxygen put in the balloon at STP will cause it to burst or not. Give your answer to one place of decimal. Atomic mass for oxygen is 16.0 and molar volume of a gas at STP is 22.4 decimeter cubed. Yes, Patrick.
Madam, the 4 grams of oxygen will not cause it to burst. It will occupy a volume of 2.8 dm cube.
Well done. And by the way, Patrick, you owe me 10 Ghana cedis. Anybody that calls me sir. All right. Next question, 10 seconds. By the way, this is the last set of questions for the round. So, 10 seconds. Explain how the bimetallic strip operates. Who? Edinaman, yes, go ahead. Patrick.
Madam, the bimetallic strip is made up of 2 metals of different expansions. So when heat is applied to the bimetallic strip, it bends. Then the outer portion shows the outer portion covers a very large surface, meaning it has a higher expansion than the one that bends inward.
Who rang next?
Bimetallic strip. A bimetallic strip is made up of 2 different metals with different linear expansivity. That means one expands more than the other when the same amount of heat is subjected to the 2 of them. So when heat is added, the one with the high linear expansivity will expand more than that of the one with low linear expansivity. So it will curve.
Yes.
The same way when...
Edinaman, there's no bonus in this round. Otherwise, I would have given you something. I was asking, I needed to hear about expansivity, you see, and you were explaining somehow, but okay. 30 seconds. Shh. What is the speed of 600 nanometer electromagnetic radiation in a transparent medium whose refractive index at 600 nanometers is 1.5? Yes. Zuera?
400 times 10 to the power negative 9 meter per second.
Incorrect. Yes, Patrick.
2 times 10 exponents 8 meters per second.
Again?
2 times 10 exponents 8 meters per second.
Yes. Last question, 30 seconds. A 5-kilogram object hangs vertically from one end of a spring of spring constant 500 Newton per meter. What is the elastic potential energy stored in the spring? Yes, which of you, Bosuma?
Madam, you have 25 meters.
That's incorrect. Yes, Patrick?
Madam, 1.25 times 10 exponent 4 joules.
That's incorrect. Tamala, you don't want it. The right answer is 2.5 joules. And that brings us to the end of the second round. At the end of the speed race, here are the scores. Osei Tutu Senior High School has 24 points. Edinaman Senior High School has 27 points. Tamale Senior High School has 37 points. Well done again. Round 3. This round has our problem of the day. The problem of the day is a single question to all 3 schools. From the time I ask you to begin, you have 3 minutes in which to present one answer from your school. The problem of the day is worth 10 points. Let's turn over our sheets and read the problem of the day together. Problem of the day. 1.0 mole of an ideal gas occupies 22.4 decimeter cubed at standard temperature and pressure. Use this information to calculate the ideal gas constant R in joule per mole Kelvin and give your answer to 2 places of decimal. State any assumptions made and show how you arrive at the final units. Contestants, this is your problem of the day. You may now begin. Osei Tutu, you are warned. Stop writing and present your answers. School name? Okay, thank you. Thank you. Contestants, please pick up your notepads and present your answers on the boards as they appear here. Thank you. Madam, come back. Lorenda. Where on this whole page do you have assumptions? So why? The contestants have presented their answers. before I award the marks, let's look at the suggested solution from our consultants. This is a problem in chemistry involving ideal gases. So we've been told that 1 mole of an ideal gas occupies 22.4 decimeter cubed as standard temperature and pressure. And we are to use this information to calculate the ideal gas constant R in specific units of joule per mole Kelvin. The answer is supposed to be given to 2 places of decimal, and then contestants were to state any assumptions that were made and to show how the units were arrived at. Okay, so this is how to go about it. In fact, you need to start with your assumptions. Okay, so the first assumption you make is to assume that standard temperature is 273 Kelvin or 0 Celsius. The standard pressure is 100 kilopascal. Okay, so those two you have assumed so that you can actually continue with the calculation. For making those assumptions, 2 points, 1 each. Now, we have been given that the volume of 1 mole of the gas is 22.4 decimeter cubed. Very good. So we have volume, we have temperature, we have pressure, we are ready to go. We start by thinking about the ideal gas equation. So we use the ideal gas equation. The pressure multiplied by the volume is equal to the number of moles multiplied by the ideal gas constant multiplied by temperature. For making this statement, bold statement, 2 points. All right, so now we can simply make the ideal gas constant the subject of this equation and then substitute the values that we have. So R is equal to PV over NT, and then we substitute. So it's 100 kilopascals multiplied by 22.4 decimeter cubed divided by 1 mole multiplied by 273 Kelvin. Okay. If you're able to go through this process, I'm giving 2 points. And then the final answer to 2 places of decimal is 1 point. And the answer from doing this will be 8.21 kilopascal decimeter cubed per mole Kelvin. You see that we don't have the units yet. Okay, so for that, those 2 steps, 3 points, right? Now we need to start converting to the units that we want. We know kilopascal decimeter cubed, right? So we can convert that to something reasonable. For the pascal, we have 10 to the power 3 pascal times 10 to the negative 3 meter cubed, right? So decimeter cubed, you are converting the decimeter cubed to meter cubed and converting the kilopascal to pascal. That's all we've done. And that gives 1 pascal meter cubed. All right. But we also need to get away from the pascal because the final answer should not be having any pascals in it. So a pascal is Newton per meter squared. So the kilopascal decimeter cubed becomes Newton per meter squared multiplied by meter cubed, and that gives Newton meter. We quickly recognize that that is the joule. When you get to this whole point of converting and getting the joule, Kelvin, mole, the ones that we want, is worth 2 points. And then the final answer is now 8.21 joule per mole Kelvin. 1 full point for this, giving a total of 10 points. This was a suggested solution from the consultants. Now contestants. Could have been better. Okay, first of all of you are making wrong assumptions. What were you saying? Your assumptions according to OSEI-22 is high temperature and low pressure when you have actually decided to use certain values. So how did they become high and low? Right, so wrong assumptions. Your assumptions, even though you didn't say, that's what you had at the bottom there, you try to sneak in. Pressure and temperature are kept constant, and the volume is calculated as standard temperature. No. The volume of the gas is negligible compared. These are not wrong statements, but that is not the assumption you need to make progress with this problem, okay? So no points for the assumptions. Now, Edinaman, Edina man, you don't even give us the ideal gas equation to make us happy. You are using it all right. Do you give it? Where is it? Okay, so yes, you have the ideal gas equation. So that gave you 2 points there for the ideal gas equation. And then you went through the process and substituted. But then you quickly jump to the units. Suddenly, the units are there. It is not the units that you actually started out with. So that was the problem there. So you had 2 points for the ideal gas equation, yes, and then 2 points for the working. The last answer I'm not giving you because you didn't go through the process. The units you had for it were not right. Okay, so that gives you 4 out of 10. All right, Tamale. Wrong assumption. You do have the ideal gas equation. That's 2 points. You went through the process of substitution, but you have the completely wrong answer. You made a mistake somewhere, your decimal place, right? You are off by an order of 10. So something went wrong there, so I'm adding 1 mark to that. Then as you were working, I saw that you were converting the units. So I'm giving you the process points for the conversion of units. That's 2 points, and that gives you a total of 5 out of 10. All right, similar, or say to 2. Ideal gas equation, yes. You get an answer, but it's not the right answer. In fact, you also jumped suddenly to the units it was later on that you tried going back to calculate the units. You do actually get a point from me for the conversion of the units from that side, but you did not complete the process. So out of the 2, I'm giving you 1, and then your final answer, well, it was an intermediate answer, had the wrong units because at this stage you don't have the units yet, right? Okay, so that also gives you 5 out of 10. That's the end of the problem of the day and the end of round 3. You may pick up your notepads. This round, I'm going to be presenting you with statements. When you receive a statement, please consider the statement carefully and let me know whether it's true or false. If you are right, 2 points. If you are incorrect, you lose a precious point. You may choose not to respond, in which case that statement becomes available to the 2 other schools. A school may ring and attempt an answer. A correct answer fetches the 2 full points. If the answer is incorrect, it fetches that penalty point. Best wishes, everyone. I'm starting this time with Osei Tutu. Your statement. 2 figures with the same size are congruent. Yes, Cadell.
False.
Yes. Please, you will speak up boldly. Edinaman, 2 figures with the same shape are congruent. Yes, Patrick?
It's true.
No. That's a false statement. Tamale, if two triangles are similar, then their corresponding angles are congruent. Zuera?
It's true.
Yes. I'll say Tutu. Sodium ions form cream-colored crystals with zinc uranyl ethanoate. Yes, Kadel?
True.
No. It's a false statement. They form yellow crystals, not cream. Edinaman, zinc metal reacts with sodium hydroxide solution to give hydrogen gas. Yes, Lorinda?
It's true.
Yes. When iron nails are put in iron 3 chloride solution, bubbles of a gas will be observed. Yes, Zuera?
It's false.
No, that's a true statement. What happens is that the Fe3 plus will undergo hydrolysis in water to give HCl, which then reacts with iron to give H2 and iron 2 plus. So you will see the bubbles. All right. I'll say Tutu. Antidiuretic hormone is released by the pituitary gland. Yes, Kadil?
True.
Yes. Edinaman, antidiuretic hormone is released by the pituitary gland when there is a balance of water in the body. Yes, Lorinda?
It's false.
Yes. The function of antidiuretic hormone is the same as aldosterone, which also helps to regulate water level in the body. Yes, Zuera?
It's false.
No, that's a true statement. The kilowatt hour is a unit of electrical power. Yes, Kadil?
False.
Yes. The watt second is a unit of mechanical power. Yes, Lorinda?
False.
Yes. The kilowatt per hour is a unit of power. Yes, Zuera?
It's true.
No, that's a false statement. I'll say Tutu. The quadratic equation x squared minus 2x plus 3 is equal to 0 has real roots. Yes, Kadil?
False.
Yes. The quadratic equation x squared plus 3x minus 2 is equal to 0 has real roots. Lorinda?
Adam is true.
Yes. The quadratic equation x squared minus 8x plus 16 is equal to 0 has equal roots. Yes, Zuera?
It's true.
Yes. If a substance added to a reaction is a catalyst, it provides an alternative reaction pathway of lower activation energy. Kadil?
False.
No. Edinaman, the half-life of a first-order reaction does not depend on the initial amount, but its value varies with the temperature of the reaction. Lorenda?
It's false.
No, that's a true statement. For a second-order reaction, the plot of concentration I of reactant against time t gives a straight line whose gradient is the rate constant. Yes?
It's false.
Yes. Or say to two. Ecologically and structurally, mosses are more closely related to lichens than to other members of the plant kingdom. Yes, Kadil?
False.
No, that's a true statement. The most commonly encountered group of bryophytes are the liverworts. Yes, Lorenda?
It's false.
Yes. The sporophyte of a moss contains no chlorophyll of its own and grows parasitically on its gametophyte mother. Yes, Zuera?
It's false.
No, that's a true statement. Last set of statements for the round. Are you getting tired? The longer the wavelength of a photon, the faster it travels. Kadil?
It's false.
Yes. The greater the frequency of a photon, the greater its energy. Yes, Lorenda?
It's true.
Yes. Last statement. The longer the wavelength of a photon, the smaller its linear momentum. Zuera?
It's true.
Yes. And that's the end of the fourth round. At the end of the fourth round, Osei Tutu Senior High School has 36 points. Edinaman Senior High School has 41 points. Tamale Senior High School has 46 points. Fifth and final round. The contest is close. In this round, I'm going to be presenting you with clues. Your objective is to solve the riddle. If you solve the riddle on the first clue, 5 points. On the second clue, 4 points. On the third or any clue thereafter, 3 points. In order to get a chance to attempt the riddle, you need to alert me by ringing your bell. May I hear your bell, Tamale? Thank you. Yours, Tedinaman. Thank you. And yours, Osei-Tutu. Thank you. When you ring, the answer must be ready. I will not wait for you. All right. There are 4 riddles in all. First one. I am a 3-digit number. I am between 500 and 600. I am an odd number. I am an exact square. Yes, Bosoma?
5 to 9.
Yes. They solved the riddle on the 4th clue, 3 points. Next one. I am a biological molecule. I was first discovered by a French chemist in 1833. I am not a rigid static structure. Instead, I have complex internal dynamic motions. When studying the fermentation of sugar to alcohol by yeast, Louis Pasteur referred to me as a vital force contained within the yeast cells called ferments. Almost all metabolic processes in the cell need me in order. Yes, Cadil.
That's ATP.
No, I continue. Almost all metabolic processes in the cell need me in order to occur at rates fast enough to sustain life. Zuwera?
Enzymes.
You are right. I read all the clues. 3 points. I am an organic liquid compound with 19 atoms in my molecule. Hey, okay, go ahead.
Oleic
Lorenda.
acid.
Pardon?
Oleic acid.
No, that's not correct. I continue. I have carbons, hydrogens, and oxygen in my molecule. I do not possess any intra or interhydrogen bonding. I do exhibit intermolecular dipole-dipole forces. I have 6 carbons in my straight backbone. Yes, Zuwera?
1 hexanol.
No. Okay, so I'll say to 2, I continue. I have 6 carbons in my straight backbone and twice as many hydrogens. My only functional group is a carbonyl, found on the 2nd carbon of the chain. So who am I? Yes, Bosoma.
Madam, we have 2 hexanol.
Anyone? Does anyone on the stage want to? Okay, yes, Patrick, for no points.
2 hexanone.
You are right. Unfortunately, I can't give you any points for that. Patience is a virtue sometimes. 2 hexanone, no hexanol. Last one. I am a tubular device that usually contains a gas at low pressure. I have a central electrode wire, which is held at a high potential relative to the case of the device. ions are produced when suitable particles enter a window that I have?
The Jamula tube.
Yes. But the pronunciation, no, is Geiger-Müller tube. They solved it on the 4th clue, 3 points. And that's the end of the 5th round. Fifth clue, not 5th round. They solved it on the 5th clue. No, 4th clue. Did I say the correct? 4th clue. No, it's okay. It's okay. At the end of the contest, here are the final scores. Osei Tutu Senior High School has 36 points. Where from the 36? Let's check the others. At the end of the contest, here are the final scores. Osei Tutu Senior High School has 39 points. Edinaman Senior High School has 44 points. Tamale Senior High School has 49 points. This is a case where I wish I could keep all three schools. Unfortunately, it doesn't work that way, so I have to say goodbye to some people. Osei Tutu, thank you for being here, for giving us a good contest. You did well. All the best. Edinaman Senior High School, thank you for being here and for giving us such a great contest. Very well done. Unfortunately, we have to say goodbye at this point. All the best to you. Tamale Senior High School, congratulations on winning the contest. It was a masterful performance, but you need to work on the true or false. Work hard on that, and it will be great to meet you again in the quarterfinals. Well done. Viewers, thank you for joining us for this really exciting 1A stage contest. We are not done yet. Next time, we'll bring you the 5th 1A stage contest, which features KNUST Senior High School, Adidome Senior High School, and Konongu Odumasi Senior High School. Before we leave, I would like to remind you that the National Science and Math Quiz is proudly produced by Primetime. We have support from the Ghana Education Service through the Conference of Heads of Assisted Secondary Schools, and we also have support from TIGO, GOL, Prudential Life Insurance, Accra College of Medicine, and GCB Bank. Thank you for joining us this time, and see you next time. Bye.